Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Aidil Haziem by Mohamad Asri. I am presenting about my final project once under the title of Tribological Characterizations of Biofluids by using 4-ball experiments under the supervision of Sir Mohamad Mazwan bin Mahad. I am presenting this for my panels, which is Sir Khairul Imran and IRTS Dr. Mohamad Ali. There are 6 main contents for my presentations. First, introductions. Second, problem statement, objective and scope of the projects. Next is literature review. Then we continue to the methodology. Number 5 is the expected result from these projects. And last but not least is conclusions. What is synovial fluid? Synovial fluid is a biofluid that located in our knee cartilage between the articular cartilage. So, these biofluids contain physiologic serum, hyaluronic acids, and proteins which are albumin and globulin and also lipids. So, this biofluid helps to ensure the smoothness of our joint motions in the body and could absorb shocks. In addition, synovial fluid also act as lubrication in human body that could reduce frictions in any movement of our joints. So this synovial fluid been decreasing when the human facing problem with their knee cartilage that is caused by osteoarthritis. To overcome this type of problem, an artificial synovial fluid is needed to be injected inside the knee cartilage to improve the lubrication in our knee joints. This artificial synovial fluids could be produced by using plant-based oil with the additives that could replicate the synovial fluid's characteristics. By using simple search keywords of artificial synovial fluids, there were 2,212 total publications from 2011 until 2021. So from the charts, we can see that the lowest publications was in the 2012, which is 129 publications, while the highest is in 2021, which is 336 publications. So, for the past 4 years, the number of publications was extremely increasing by 70.6%. So, it shows that these topics of artificial synovial fluids still getting attention from many researchers. Next, we move to the literature review of my projects. The table below shows the journal summary. First is the journal paper that written by David Nichols. In the journal, it states that he conducted an experiment by using ball-on-disc thermometer to study about the coefficient of frictions for several models of synovial fluid, which consists of pure saline and proteins, using 2 different speeds of the ball and the disc. So there is still gap analysis between his project and my project, which is first is type of biofluid used, and second is he do not study about the effect of load of the biofluid, and also he do not compare the waste diameter for every sample. Next is the journal paper that written by S. Charolal. In the journal, it states that he conducting the test by using 4-ball thermometer and follow the standard of ASTM D4172. He studied about the coefficient of friction and waste diameter for 7 types of test lubricants that consist of different volume of palm fatty acid as the additive, and the base oil is the commercial methyl oil. The gap between his project and my project is do not test on the effect of variations of loads applied to the biofluids, and also he only used one additive, which is different with my type of additive, and only use one concentrations of the additive of the palm fatty acid distillate. Next is the journal paper that written by T. Cheong Ing. In the journal, he states that he conducted an experiment by using 4-ball thermometer to study about the effect of different types of fluids and viscosity of fluid in terms of its coefficient of friction, waste diameter, and wear-worn surface characteristics. But there is still a gap between his project and my project, which is first, he only used and do testing for one plant-based oil, which is refined bleach and deodorant palm oils. He also do not study of the effect if the oil will be going to blend with additives such as hyaluronic acids. Next is the journal paper that written by Benedict Rodhammer. He do the analysis of density by using digital YouTube oscillator density meter and the analysis of viscosity by using stress controlometer. In the journal, he states that he used Boivin serum as simulated synovial fluid to study about the effect of temperature on the shear rate dependence of the dynamic viscosity. There is still gap between his project and my project. First, the usage of different type of base oil as the artificial synovial fluid, and he only studied on the effect of temperature on the shear rate and viscosity of the fluid. He did not study the effect of the loads and the different concentration of additives used into the friction coefficient and friction torque. From the journal summary, I can conclude that there are some journals that use the same methods or experiments with my project, which is using the four-ball experiments. However, there's still gap or the component that did not study by the researcher. First is the type of base medium oil that we use. I will be going to use the plant-based oil as the base mediums, which is canola oil. Second is the different type of additive concentration that we use in my project, which is different type of concentration of hyaluronic acid, which is 0.5%, 1%, and 1.5%. Last but not least, the gap of the study the effect of increasing loads on the friction coefficient and friction torque. This is problem statements of my projects. The key issue is using a plant-based oil, which is canola oil, as the base mediums of the biofluids, and also determining the suitable concentrations for the hyaluronic acid as an additive that's safe and suits with humans. So, in order to produce the better artificial synovial fluids, it must having smaller coefficient of frictions and also produce a smaller wear scar diameter. So based on comprehensive literature, there is still lack of research and data on these types of canola oil as an artificial synovial fluid. There are two objectives in this project. First, to determine the coefficient of frictions and the friction torque of the biofluid from plant-based oil by using four-ball experiments. Next, to study the effect of the plant-based oil, which is canola oil, on the Westcar diameter produced at the ball bearing based on the concentrations of hyaluronic acid. Next is scope and limitations in this project. First is the biofluids, which is we will use the plant-based oil, which is canola oil, and the additive, which is hyaluronic acid with the ratio 8:2 of 10 ml volume. So the concentration of hyaluronic acid that we use is 0.5%, 1%, and also 1.5%. Next is standards. So in these four-ball experiments, there is two conditions that will be measured. First is extreme pressures by following the standard ASTM D4172, and also the wear preventive conditions which follow the standards of ASTM D2596. Next is the parameter that will be used in this project is temperature, which is 75 and 30 degrees C, speeds 1200 and 1760 RPMs, and also load 40 and 100 to 315 kilograms, which is this parameter is different for the two conditions of the extreme pressure and wear preventive conditions. Last but not least is this project is only study and analyze about the coefficients of friction and friction torque of the biofluids and also the wear scar diameters that produced at the ball bearing. This is the methodology that we use in this project. First is sample preparations, which is I will blend the canola oil and the hyaluronic acid with the ratio 8:2 for 10 ml of sample. The concentration of HA is different for three samples. First is 0.5%, second is 1%, and 1.5% for the third one. Next, after sample preparation, we go to the apparatus setup, which is I will use the tribological test using four-ball experiments. I will have to clean up all the apparatus such as ball bearing and ball pods with inhabitant to ensure it clean and do not interfere my results. Set up the apparatus such as I will put the ball bearing and pour the 10 ml of sample in the ball pods. Next is run the experiments under two conditions. First, extreme pressure condition, which is load from 100 until 315 kilograms, speeds 1760 RPM, while the temperature is 27 degrees. The load is increasing until the well occur in the series of 10 seconds. After that, we will get the result for objective number 1, which is coefficient of friction and friction torque. Second condition is wear preventive condition, which is load of 40 kg, speed 1200 rpm, and also the temperature 75 degree. This condition will be run for 1 hour. Next, from the conditions we get the result for objective 2, which is Weska and surface result. So lastly, I will do comparison with another researchers and validates my results. This is the expected result for this project. In this project, the coefficients of friction and friction torques of the biofluids being analyzed depends on its relations with the applied load and also the concentrations of hyaluronic acids. In this project, we expect that the higher load will increasing the value of the coefficients of frictions and also the friction torques as the figure below. So each sample having their own trends for the friction coefficients and also friction torque. Next is the expected result of this project on waistcoat diameter. Analysis for this result, the characteristics of the scar produced being studied in terms of its size and shapes. Every sample having their own different characteristics of the scar produced. The result of ball bearing be measured under the optical profilometry. From the figure below, it shows the example of the wear scar that been produced on the ball bearings in the experiments of 4-ball experiment. Next, we move to the conclusions for these projects. First, I am able to determine the artificial synovial biofluids, which is by using the canola oil as the base medium oil and blends with the hyaluronic acid as an additive. Next, I am able to use 4-ball experiments to achieve the objective in this project, which is first to determine the coefficient of friction and the friction torques of the biofluids. Second is to determine the waistcoat diameter produced at the ball bearings. Last but not least is a clear understanding of these projects had been solved, and I'm able to proceed to the next phase of this project. This is the Gantt chart for my projects. This Gantt chart is combinations of my progress for final year project 1 and also final year project 2. So Gantt charts help me to organize my projects, improve my overall project visibility, and keep my progress of this project on tracks. These are the list of references that we use in this project. Thank you for your time listening on my presentations. Do you have any questions? Feel free to contact me through the email and contact number below. Thank you.